Okay, so this is Chemistry 5.1, the bonding and structure past paper, okay? So the first question asks you to draw a line between each type of structure and its property, okay? So the first thing I did when I was answering these types of questions is I worked out what kind of bonding would be taking place. So in metallic bonding, it would be a metal. In ionic bonding, it's metals and non-metals, things like that, okay? Then metallic bonding, you know that metals are malleable and ductile. Ionic bonding was already done for you. Non-metals is, so simple molecular is a liquid or a gas because they're the smallest ones. And then giant covalent, they have high melting points because the giant covalent bonds are repeated over and over again, okay? Moving on to question number 2, which was about nanoparticles. As you can see, I've highlighted what would have been the words I needed, the command words and the key words, okay? Explain why nanosilver is suitable for use in these examples and state why some people are still concerned about nanoparticles. Nanosilver, I wrote, was 1 times 10 times smaller than normal silver, okay? So it's got different properties from bulk silver. It has antifungal and antibacterial properties, which is why it's used in socks and plasters. The biggest concern with nanoparticles is that they are still so small, they can get into your blood through your skin, and they can also end up in water, which has a giant effect on marine life and plants. Moving on then to question number 3, which was identifying structures. So first thing I did again was label all the structures, work out what they were before I even started answering the question. So give the letter of the structure that represents diamond, that is C. Diamond has got that unique structure where it's got 4 carbons all bonded to each other over and over again, okay? Which is how you can tell the difference between diamond and graphite, because graphite's only got 3 carbon bonds. Question B was a tricky one. Name an element. So it's not asking you to name the structure, it's asking you to name an element that would be represented by that structure, okay? Structure D is a metal, so I just picked any metal, copper. Any metal would have done, aluminium, potassium, any metal would have fit the answer for that. Give a structure that's able to conduct electricity. Well, you should all know that metals are able to conduct electricity. The other one you could have written was A, which is graphite, because graphite have the free carbon bond, which means free electrons, which allows it to conduct electricity. Give the structure that represents sodium chloride. Sodium chloride is a giant ionic structure, so B was the answer to that. Moving on then to question number 4. Question number 4 is quite a common type of question that you should expect to see at least once in the chemistry additional paper. It is drawing the ionic bonding between a metal and a non-metal. Okay, I've also highlighted that you need to draw a dot and cross diagram, and also you need to make sure that you draw the formation of the ions at the end, okay? So the first thing I did was I drew out what they look like currently. It gave you a little bit of a hint because it told you that lithium was 2-1, so it means 2 electrons in its first shell, 1 in its second shell. It also gave you the same for sulfur then, saying it had 6 in its outer shell. Now, if you just put 1 lithium molecule like I did in the purple pen, you can see that it still didn't have a full outer shell, so you have to have 2 lithiums. So 2 lithiums transfer, then sulfur's got full outer shell. Obviously lithiums have both got full outer shell then because they've lost that outer electron. Written on the side there, so positive means they've lost an electron, so you have 2 lithiums and they both lost an electron. And then sulfur's gained 2 electrons, and I've drawn out its final structure, so it's 2 negative. Sodium chloride and magnesium oxide both have giant ionic structures. The melting points of the 2 compounds are shown below. So the first thing I did is I worked out what the charges would be if I bonded these 2 structures together. Explain the difference in melting points of the 2 compounds. Magnesium oxide have larger charge because they're 2 plus and 2 minus compared to sodium, which is 1 plus, which means there's a larger electrostatic force. Larger electrostatic force between that positive and that negative ion, meaning more energy would be required to break the bonds when melting, etc. Part C of that question then was bringing in the other type of bonding that you have been taught, covalent bonding. Straight away, I know it's covalent bonding because it's two non-metals, hydrogen and oxygen. You can see the structural formula. The first thing I did was look at the bonds, okay, because you've got 4, which might be a little bit different to the ones that we practiced in class. You have got 4 elements and 3 bonds. So I've drawn out in the green pen exactly where the sharing of electrons takes place, and then at the bottom I've drawn a new structure showing exactly where the electrons are shared. Okay, expect that kind of question because it's a little bit more difficult than simple things such as water. Moving on now to question number 5, talking about the difference between simple and giant covalent bonds. Covalent bonds are formed by the sharing of electrons. Again, I've highlighted the key words. The diagram below shows the structure of oxygen and diamond and diamond is a form of carbon. Explain why diamond has a higher melting point than hydrogen. You can see in the pictures that hydrogen only got one bond, one line between the 2 hydrogen atoms, whereas diamond is bonds over and over again. And I've written diamond is a giant covalent structure, whereas hydrogen is a simple covalent structure. Diamond has numerous bonds, whereas hydrogen only has one bond. Numerous bonds would mean that there's more energy to break the bonds. So each of them bonds is going to require a certain amount of energy. Obviously, diamond's got way more. Graphite is another form of carbon that has a high melting point. Give one other property of graphite and explain its property in terms of structure and bonding. Graphite, unlike diamond, can conduct electricity. That is because it only has 3 carbon bonds compared to diamond's 4 carbon bonds, which means it has free electrons to conduct electricity. Moving down then to the bottom, the bonding in oxygen is also covalent. Draw a dot and cross diagram to show the bonding present in a molecule of oxygen. Again, using the green pen, I've shown where the sharing would take place, and then I've drawn it out again at the bottom, showing where the electrons are shared. And then the final question on the bonding and structure paper was a 6-mark question. Thermochromic pigments, photochromic pigments, and shape memory alloys are all types of smart materials. Describe your understanding of smart materials. Your answer should include what is meant by a smart material and some examples of smart materials. Okay, so the first thing I did is I went down the bottom. I didn't actually answer the question straight away, and I started thinking about that TICS anagram. What is the topic you are being asked? How many marks? So it's 6 marks. You need to be thinking of 6 points. What are the command words? So this one was describe, say what you see. What are the keywords or keywords that I might want to put in my answer, and then thinking maybe about a sentence starter to get me started. Okay. I also then thought about how I would arrange it in paragraphs because it's told me what my answer should include. So the first paragraph then I wrote like a basic overview of what a smart material is. So a smart material is a material is a molecule which reacts to change in its environment, normally temperature, heat, or light intensity. So that's my first paragraph. Then it said to just give me some examples of smart materials. So moving on to my second paragraph. Thermochromic pigments change colour when temperature changes. These are used for forehead thermometers and mugs to ensure that you don't get burned. And then finally in another paragraph I wrote shape memory alloys remember their original shape when heat is applied. They're used in car bumpers to remember their original shape in an accident so they can be returned to normal. Okay. I've also noted out in the pink pen where the marks were. So 1 mark for that first paragraph describing a smart material, then 1 mark for giving an example of what a smart material's environmental change is, and then another mark for saying where it would be used. Then the same thing then going down to paragraph 3, another mark for saying what the smart materials change the environment is, and then 1 mark for saying where it would be used, and then 1 mark at the end for SPAG and organisation.